Learning Legends, it's Prof G, and it's time for a couple of challenges based on what we've just learned about NeoPixel strips in the Raspberry Pi Pico. Programming success involves lots of practice. It's sort of like learning a foreign language. The more experience you have, the better you'll become. Now we'll give you a couple of challenges, and in the solutions, I'll show you some new concepts and ways to make your code even more efficient. Let the hacking commence! So in the prior lesson, we learned to set up a NeoPixel strip and flash colors in an infinite loop. Let us use what you learned to tackle the Rainbow Flash Challenge. First, delete everything in code.py, so you start from scratch and make sure you understand all the setup concepts that we covered. Then search online or use AI to identify the RGB values for the 7 roy-g-biv colors of the rainbow. And once you have those, write and run a program to flash each color red, orange, yellow, green, blue, indigo, and violet, showing each color for a quarter of a second. And repeat the pattern forever until the board is unplugged or the code is stopped. Now, a couple things to note. I found that the examples that AI gave me weren't the best choice for RGB values that were appropriate for NeoPixel colors. Sometimes this happens. The light RGBs don't perfectly match real-world examples. Try your best. You can make modifications if you want to, but later in this lesson, I'll give you some examples that I think work better, especially for orange, yellow, indigo, and violet. But I'm going to do this when introducing concepts around variables, so do watch the solution, even if you got the answer that you think is correct. Also, I'm going to deliberately make some mistakes when I present the solution. I find it's often useful for students to see common errors and the thought process you might go through to recognize and deal with them. So why don't you pause, give this a shot. I'll bet you know how to do this. But as you're learning, it's totally okay to go back and rewatch portions of the prior lesson or pull up code examples to remind you how things work. Makers rarely memorize everything. Your old code will serve as great notes. And when you're done, resume and let's compare answers. Now, at the end of the last lesson connecting our NeoPixel strip to our Raspberry Pi Pico, I said that in the next lessons we would be setting up CircuitPython and PyCharm. And if you did that, great, but I also realized that some of you might want to keep coding, so I'm showing you one more code lesson before those installation lessons, just to feed that flashy coder motivation that you want to keep nurturing. So if you want to code this in PyCharm or another editor, dive in, but for those of you that can't stop, I'll show this using the web-based online code editor at code.circuitpy.org. Well, you can see by my desktop that I've already got my Pico plugged into my computer. It's mounted with the name CircuitPy. So I'm going to open up the Chrome browser, and I'm going to go to the online editor at code.circuitpython.org. Then we select USB. Since I'm connected via USB, connect to device. Select the one with USB modem. I can see that my Pico here has the name Pico 2 in it. Blinka swirls. There's another confirmation to use the volume named CircuitPy. And remember, that's what my Pico board is named, and it appears with that name on the desktop. And I know this is a bit weird and confusing because you just selected a board with Pico in the name, and now you're selecting a volume called CircuitPy. That's the name that's used on the desktop. It's quirky, but those are the steps to use the editor. Then we've got a blank editor on screen, but remember, we need to load up our program on our Pico. And do you remember what that program that runs is called? It's called code.py. So let's click open, we'll click code.py and open again, and we're ready to start. And I'd mentioned that you should delete everything and start from scratch, so that's what I'm going to do. Command A or Control A to select all and then delete. And now I'm going to enter a comment in my first line. And in that comment, I like to enter the name that I'm going to use to name this program when I save the backup version in the CircuitPy folder on my computer. So after the hashtag, which is the comment character, remember, while our code is called code.py on our CircuitPy board, when I save it to my computer so that I can recognize all of my different code examples, I'm going to call this roy-g-biv-pico.py. Next comes our first real line of code, and that's our imports. Remember, base Python doesn't know about the board, time, or NeoPixel libraries, so by saying import board, time, NeoPixel, we expand Python's vocabulary so that it knows about all the commands and data structures that are in those libraries. Cool. So after expanding our Python vocabulary with the import statements, and I'll put in a comment to say this, we're going to set up our NeoPixel object named strip. Remember how we do that? First, we give the NeoPixel strip a name, and we could call this anything, Jennifer or Lady McLightface. But since this is a NeoPixel strip, we started calling it strip, which is an excellent name. And we set this value named strip equal to the command we want to use is in the NeoPixel library, so we type in lowercase NeoPixel, the same name as our library, and we want to go into that library and get the NeoPixel class. To do that, we use dot notation, go inside the thing on the left. The NeoPixel class is spelled with a capital N, capital P, And remember, a class is like a blueprint. So we want to go to a factory to build something from this blueprint, which is what we do when we use parentheses and pass in values into that class. So we'll start with a parens, and inside the parens, we give the location where we can find the signal wire that our board is attached to. And to get to that, we go to board, which is another library. And when we installed CircuitPython on the Pico, the board library for Pico knows all about its pins. If you installed CircuitPython for a different board, the board library for that board would know all about that board's pins and pin names. The board library was included by default, so it's not in the lib folder, it's built in, and this knows about all the pins in the Pico. It also knows they all start with GP, capital G, capital P, which stands for general purpose, followed by a number, and the pin that we wired things to was board.gp16. If you connect your signal wire to a different pin, just use that other pin's name after board dot. Then comma to move on to the next input. Then we list how many NeoPixel lights are in the strip object connected to GP16. For us, that's 30. Have a different number of lights. Put the correct value in here. And then we say comma. We don't need full brightness. The strip is very bright as is, so we're going to say brightness equals 0.5. That dials the brightness down to 50%. Cool. Quick concept, strip is what's referred to in computing as a variable, and I like to think of a variable as being a named box that contains data. Now in this case, we created a box named strip, that's our variable name, and it contains all of the information about our NeoPixel strip. So whenever we refer to strip in our code, our program is able to sort of look inside that box named strip, and there it finds information on our NeoPixel object that's connected to the board's GP16 pin that has 30 lights and is set to 50% brightness. Now being able to say strip is super handy, because instead of all this information we wrote up here, we just say strip. That's one advantage of using a variable. It's a concise way of referring to the data that makes up a value. By the way, Python is super fussy about getting capitalization right, but this can confuse new students because we have some words that are in all caps, some that are in mixed caps, and some that are in all lowercase. Well, the reason for that is there are different conventions or styles that programmers use for different types of data or data structures. Now, one convention is to write class names like NeoPixel here as one word, but with a capital letter at the start of each of the sort of words inside of the word, like capital N Neo, capital P Pixel. That's referred to as the UpperCamelCase style, since the capital letters look sort of like the humps of a camel. Now, you'll also notice the convention is for variable names like strip, function names like print, as well as library names like board and NeoPixel, to be written in all lowercase letters. And if a variable has more than one word in it, the convention is to use an underscore to separate the words, and that style is called snakecase. And there's another style that we'll see later in this lesson. Values that should remain unchanged and constant should be written in all caps. So we'll see this later when we create values to hold colors, like red or blue. Now when you think about it, blue should always be in parentheses 0, 0, 255, and that should never change. Blue would never become a different combination of numbers, so the convention is to write these unchanging values, like blue, in all caps. And now that we've got our strip created, I'm going to put a comment in here saying turn off all the lights to start. And to do that, I'm going to use the fill function that we learned about in the last lesson. So I'm going to say strip, the name of my object, then dot notation to access the fill, F-I-L-L, function. So a function is just a piece of code that can be called and run, and it's sometimes useful to think of functions as being the verbs of computing. Now the fill function is built into every NeoPixel object, and since strip is a NeoPixel object, strip has a fill function. Now as we mentioned earlier, all functions need parens, so I'll type an open parens, and in here I'm going to pass in the parameter that fill needs in order to perform its task. So it needs a color. Now in the last lesson we learned that we can write colors as three values, 0 to 255 separated by commas, and those values represent the amount of red, green, and blue light to use. 0 is no light, 255 is the maximum amount we can use, and since we want to turn off the lights, we're going to say in between these parens 0, 0, 0. Everything's dark. Now one more quick aside, and I know you're getting a lot of terms here, but this is one you're going to hear regularly in computing. Now while fill is a function, it's a special kind of function, and the term is method. A method is a function that's attached to an object. So see how we have dot notation here where we follow strip with dot fill? That means fill is attached to the object named strip. So all methods are functions, but they're specifically functions that are attached to objects. Just another term that programmers need to know. So now that we've set up our strip, we've turned off all the lights, let's flash those lights once for each color, keeping each color on for 1/4 of a second. And once we go through all the colors, we'll want to repeat that pattern forever. Remember from our prior lesson how we create an infinite loop? We just start with the word while, space, capital T true, with a colon afterward. If you get any part of this wrong, the capitalization or the colon, your code won't work. Then I'll press return, and the editor knows I just entered while true with a colon after. And the editor knows that everything underneath this should be indented so that it's repeated inside the loop, so it starts me indented on the next line. and here's what I enter for the first line for my flashing pattern code. Strip, the name of our NeoPixel object, .fill, the method of that object that will fill the strip in with a given color. And all methods and functions have parentheses, so I'll enter the first set of parens, and then all colors also have parentheses, so I've got a second set of parens in here. And inside this, I'll add the RGB values for red. That's 255 for full red, comma 0, no green, comma 0, no blue. And then I'll enter a comment after this indicating that this is red. And I've asked you to search online for the RGB values for the roy-g-biv colors. So what I'm going to do is I'm going to open up a new browser tab and go to Claude.ai. That's the AI tool that at the time of this recording I think is the best at CircuitPython, but really anyone should do. And I'll ask Claude to give me the values for the roy-g-biv colors of the rainbow in the format parens R, G, B, where the RGB values are from 0 to 255. And Claude thinks and delivers these values. They're okay, but I'll tweak them later. This is a good start though, so I'm going to copy this entire line here, then close this tab and paste the line into my code. Now what I just pasted in is not a valid Python command, but I'm just going to use this so that I can cut and paste the values that I need. And one thing I can do is cut out this first red line that I pasted in here and put it as a comment above strip.fill for red. And then here's a pro tip. I want to indent all of these other values so that they're part of the while true loop. Remember, all values under while true need to be indented below while true so that they repeat. So I'm going to highlight all of these values, then press the tab key, and that indents them all together. Then I'll add a comment character in front of all of these other values, and then below each comment I'll add another strip.fill with its two sets of parentheses, but then I can copy and paste each of these RGB values below, and these 7 statements should fill the strip with the 7 roy-g-biv colors. Now remember, I said I'm going to deliberately make an error here, and even if you wrote correct code, you might want to make this same error here by modifying your code so that you can try this out and you can recognize what happens when you get an error like this. Some of you might already have encountered this error, so I'm going to accidentally highlight a left parenthesis when I copy my RGB values for violet in the comment up here, so that when I paste this down below, look at this. I've now got an extra parenthesis on the left-hand side. See how there are 3 in here? There's no matching parenthesis on the right-hand side. I only want 2 parentheses in here. This is going to generate an error, and we'll see this, but before I save and run, I also like to add a print statement above my while true statement. I always add a print statement just so that I can take a look and make sure that my code is running and that I've reached that part of my code. This can be really useful when debugging if there is a problem with your code. So above while true, I'll say print parens and then double quote for our string, and inside the quotes I'll say roy-g-biv pico is running. And now I'll click on save and run, blink a swirls, and dang, we have an error. And the code runs twice, which we mentioned in the previous lesson happens the first time you save and run in your coding session, but we see down here we have code.py output, but trackback below helps us trace the line where the code broke because of the error. Now here it points us to the file code.py in line 26, and it says syntax error : invalid syntax. Now a syntax error is sort of like a spelling error. I typed in a statement that CircuitPython can't recognize. Now curiously, the output says it occurred in line 26, but I don't have a line 26 in my code. I do have a line 25, and this sometimes happens. The error might not be on the line mentioned, it might be on the line above it, so look around. And again, we're going to begin using the PyCharm editor, which does a much better job of helping find errors. But we're in the online web-based editor for now, and if I look closely at this line, I want to look at the syntax or structure of this statement. Does anything look incorrect? So typically you count up things like parentheses and quotes to make sure that there's a matching pair. Also look for any spelling or capitalization errors in your keywords, and sure enough, we see the triple parens that we'd entered earlier. We only have double parens on the right, so if we remove one of the left side parens, our code should now work. Let's try this out. The save and run button is gone, but we know that we can simply press save, and that saves the code and automatically executes our changes. Blink a swirls. The line below says code.py output roy-g-biv pico running. Great, we have evidence that our code is running at least through this print statement, but oh, we have a second issue. The code doesn't crash with an error. We're not seeing any problems in the console, but our code is showing white lights, which is weird because we didn't set any colors to white. What gives? And if you're wondering how do we get white, well, if you add full red, full green, and full blue, so between parentheses 255, 255, 255, that gives us white, but that's not what we entered in any of our lines here. Each line is a distinct 3-value color. All of them are different. None of them are white. So can you think what might be going wrong here? It's not especially intuitive, but the problem is I didn't pause after each strip.fill command. Now here's what happens. Our Pico is actually executing code so quickly without any pauses in there that it flashes through all the colors and they seem to blend together and turn up as white. So let's fix this. And I actually mentioned the challenge that you should pause after each color for 1/4 of a second. Well, we learned how to do that in the last lesson. We just use the sleep function that's part of the time library. Also, quick pro tip, if you want to hide the serial console output area so you give yourself more space to code, you can just click on the serial button in the bottom left of the window here to toggle it open or closed. And now in my code, underneath where I set the color to red, I'm going to add a line, time.sleep, and between single set of parens, I'm going to add 0.25 for a quarter second. Then I'm going to copy this time sleep line, and I'm going to paste it below the 6 other strip.fill statements. And so now in the code, every time I strip.fill, to change the color, I should pause or sleep for a quarter of a second before moving on to strip.fill the next color. The delay should allow me to see each color for a quarter of a second. Let's click on save, blink a swirls, and hey, call the Skittles company. I'm flashing the rainbow. But I'm also not seeing the serial console, which is useful if you have print statements or you want to see if any errors have showed up. But remember, you can just click on the serial button and that toggles it open again. We see our print statement for this run. No errors. Nice. Now here's a technique I'd like to show you regarding variables. So let's say you want to change the value for the color pause, the time that we pause after each color is being shown, from a quarter of a second, which it currently is, to a tenth of a second. Now that would make the strip flash even faster. Well, I could go down here and change 0.25 to 0.1 in every time sleep statement, that's 7 times, but that would be tedious if I were experimenting to see what time might work best. Let's say I give that a try and I say, oh, too flashy, I want to go the other way, I want to set things to 0.5 seconds, well then I'd have to update 7 more times each of those individual time sleep statements. And that occurs because we've entered what programmers call a literal value as the parameter that we pass into time sleep. So a literal value is when you type in an exact value, say a number, text for a string, or a color as parens with 3 numbers. Now it would be much better if we had a single value that I could change, and that value would be applied to all of the time sleep statements. And we can do that with the strategic use of a variable that replaces the literal values. Code along with me, we'll do this together. So before I hit my while true infinite loop, above this, I'll first enter the comment, create a variable to hold the time to pause each color, and then I'll name this value color_pause, all lowercase. So this is snake case, which is what we use for variable names. And I'll set this equal to 0.1. So remember how variables work. I have a box named color_pause, and inside of that box is the data 0.1. So in my code, wherever I refer to color_pause, we get and use the data that's inside of that. It's currently 0.1. Now watch this. We can copy the name color_pause here, then paste it over all of the literal values in the time.sleep code. And when we do this, we're no longer using literal value as our sleep parameter. We're using whatever data is inside color_pause. Save this, the console moves, it prints again, no errors, and look at this. Our code is executing just like it is before, but now we're using a variable instead of a literal. Now since we changed that variable to 0.10, our flashes are happening at a tenth of a second instead of a quarter of a second. But here's the best part. Let's say we want to slow things down so that the color pause is 0.5 seconds. Now I only have one value to change. I'll change this line color_pause and set it equal to 0.5. Now save and run, and look at this. Our colors are lingering for half a second instead of that rapid 1/10 of a second flash. And to make that happen, I only had to change one value in a variable instead of 7 lines with literals in them. Let's try one more change. We'll slow things way down with 3 seconds as our color delay. Save. Oh, and look at that. Things are much slower, but we see we only needed to change that one line for it to impact 7 other lines. Now you see how you can leverage variables as a superior solution to literals in any case where you think you might want to update those values in the future. Variables that have a good name also make your code more readable. You can look at this and say color_pause instead of wondering what 0.25 is, and it makes your code more maintainable. Someone comes in here and wants to change that value, they now only have to change it in one place. So now that you know how to create and use a variable, let's issue another very quick challenge. So this will be the Pico Rainbow Flash with Black challenge. Modify the roy-g-biv pico.py code. You can save this code to your CircuitPython school folder first if you'd like, then change code.py so that you pause for a quarter of a second after the strip is filled with a color, then turn the strip to black and wait for 1/10 of a second before resuming to turn the colors on in the next color. So use a second variable named off_pause to hold the length of time the light should be turned off in between flashes. Initially that'll be 0.1. The effect should be each roy-g-biv color is on for a quarter of a second, then the light should turn off for a tenth of a second, then the next light on for a quarter of a second, off for a tenth of a second, etc., over and over again. Now once you get this working, make some changes. Why don't you try changing the two variables color pause and off pause to half a second. That should flash the colors on for half a second and off for half a second. And when this is working, we'll save this to our CircuitPython school folder as roy-g-biv flash with each color off.py. So pause. I bet you can do it. Give it your best shot. Then resume, and let's compare answers. So first I'll create a second variable under color_pause, and I'll call this new variable off_pause, also lower camel case. I'll set this equal to 0.1. Oh yeah, and remember the challenge asked us to change the color pause to 0.25 so that each color is on for a quarter of a second. And now we want to turn the lights off for the length of off pause after we're done pausing for the length of time the light should be on. So let's do this first down here in red. After we're done with time.sleep color pause, this means we're done showing red. Now instead of showing our next color, what we're going to do instead is we'll fill the lights in with black. So we'll say strip.fill, open parens for function, open parens for color, then 0, 0, 0, which are the RGB values for black. Then I'll time.sleep, passing in between the two parameters off_pause. That's the length of time I want the lights to remain off, and that's it. But I've got to repeat those two new lines 6 more times, so I'm going to copy the lines and then paste them after each time.sleep color pause line. And now if we save, no errors, legends, we've got each color on for a quarter of a second, followed by a tenth of a second off. Brilliant. And now let's change our two values. So color pause and off pause should both be 0.5 as requested in the second part of the challenge. Save to run. And we see slower flashes with the colors on for half a second and off for half a second, all repeating forever inside of our while true loop. Nice. And there's one more thing I'd like to do, and I want you all to follow along with me because this is going to be a good chunk of code that you'll probably want to reuse. I want to give you what I think are the more accurate colors for the roy-g-biv colors. So we're going to create a variable for each color, and then I'll give you values that are actually the official CircuitPython values for these colors. Now, since the colors are going to be unchanging or constant values, red is always red, green is always green, we'll use all caps for the names. So I'll put a comment in here that says define colors, and my first will be red in all caps, equals parens 255, 0, 0, and then I'll write each name in all caps followed by equal and parens. So orange, yellow, green, blue, indigo, and violet. And here are the RGB values for each. And in a future lesson, you'll see these values are actually the official color values that are used in CircuitPython. That'll come up in our lecture on LED animations. But orange is 255, 40, 0, yellow is 255, 150, 0, green is 0, 255, 0, blue is 0, 0, 255, and at this time CircuitPython has not defined an official color for indigo and violet. Now there is a purple, so I set violet equal to purple, which is 180, 0, 255, and I put a comment after here that said purple, and I made up the indigo values. So I thought 70, 0, 130 was good, but I'll also put a comment here that says no official indigo from CircuitPython. And now in our code, everywhere where we had a color literal, we can replace this with an easier to read variable name. And one thing that's nice is you can see as I start to type in a variable name like red, RE, code completion knows this variable exists. It pops that up as a suggestion. That can make your code entry way faster, and using code completion can help eliminate spelling errors, and you no longer have to commit the colors to memory. And while we're at it, why don't we create a black equal to in parens 0, 0, 0, and white equal to in parens 255, 255, 255. So I'll replace these colors everywhere, and I'll also delete the comments that state the colors since the variable name makes it obvious which color I'm using. And just to make my code a little bit more readable, I'm going to put in a blank space after each color flash and light turnoff, and I won't speed up this part so it's easier for you to compare my code with yours. Adding that extra white space is totally fine. You just want to make sure that you don't outdent. Remember, everything's got to be indented underneath while true. And now let's save this. So I'm going to go up top and, oh yeah, I should have changed the name in the comment on the first line, roy-g-biv with Pico flash each color turnoff.py. And just to show things are changing, I'm going to copy the name up here and I'm going to paste this in my print statement down below. Run this, and oh dang, my friends, I've got an error. What did I do? I could have edited this out, but I wanted to keep it in so that you can see that I make errors too and how I diagnose them. It says line 42 has a syntax error. Ah, I see the problem. Can you see it? It's actually, once again, not in the line that was mentioned. It's in the line above this. I must have deleted the closing parens in green. So I'll add that paren, fix that very common error, Save this and run, and things are looking great. So now we've updated our roy-g-biv colors so that they're more or less the official ones that are used by CircuitPython. We added our own indigo, we said purple was violet, and now you've got this really nice chunk of code, and we can save this file, but you should know that you can also open up this file and copy out the chunk of code and paste it in whenever you want the roy-g-biv colors and black and white. Makers regularly copy and paste lines of working code from one file to another file. It makes the setup far less tedious. It also makes sure that you're using a reliable code that you've already tested. Just remember where you've got those color constants saved. I'll once again use this name that I put in the comment in the first line of code as I save this to my CircuitPython school folder. Nice! And hopefully, Colorful Coder, you feel like we've once again acquired some big learning. We learned about variables, variable naming conventions including classes in UpperCamelCase, variables, libraries, and functions in SnakeCase, and constants in all caps. We learned the key term method, a function attached to an object. We coded examples that showed the advantages of variables over literals, including code that is more readable and maintainable, the potential for fewer errors, and faster and more accurate coding with code completion. We also learned to recognize syntax errors and saw how we could fix some, including noting the need to look above the line that's flagged as the error line. We once again got a bunch of pro tips, including highlighting code and pressing tab or shift tab to indent or outdent. We learned that colors that flash too quickly might blend together to form a new color, like white. And we coded a better roy-g-biv with official CircuitPython colors, and we saved these so that we could pull up that work, copy, and paste those colors in, so we don't have to tediously enter code each time we want any of the rainbow colors. Creative Coder, I hope you like your projects now that you've got some flashy finesse, but be sure to install CircUp and PyCharm in the next lessons if you haven't already. Those will be huge helps as we strive to make awesome things and continue to hack.